So we've been working with complex numbers and specifically with raising them to different powers and what we can determine from raising them to different powers. And so I've got a couple questions from people about some trickier looking problems. So let's look at this one here, which usually when there's a exponent that's this big, it means there's some sort of general pattern that you should be looking for rather than just trying to brute force it. So we've got this raised to the 2019. I guess that was when the question was written, probably. So there's definitely something going on here. The first thing that I notice is that neither of these is like really written in the right format. Usually, what we're thinking of with our complex numbers is, we've got our a plus bi, which we can write as r cosine theta plus ri sine theta. Neither of those are really like in the right format to do that. I do notice here that the r value is equal to 1, but I'm not seeing things in the right format. So anyway, a couple different ideas. I'm not sure exactly what the best way to go is. One idea that I have is maybe I could use the fact that cosine of negative theta is the same as cosine of theta, and sine of negative theta is the opposite of sine theta. And by the way, these are um, pretty clear where these come from if you just think about rotating theta degrees up and rotating theta degrees down. I hope you'll see that where you end up with has the same x value. In other words, the x value up here is the same as the x value down there. Well, that x value is cosine of theta, and this x value is cosine of minus theta, so those have to be the same. And same idea here, this y value is a certain sine, and it's going to be the opposite of this y value down here. Okay, so that's where I came from those. So one idea I have is like, okay, I could rewrite this as negative theta, and I could rewrite this as negative theta, and turn this into a plus. That'd be good. The top still isn't quite in the right version, but I think I might be able to massage it into the right version. So I'll keep going with this idea, and then I'll circle back and see if there's another way to do it. So I see the top sine theta plus I cosine theta. I'm just copying that down because I haven't thought much about how I'm going to deal with it yet. And then the bottom I can write as cosine of negative theta plus I sine of negative theta. So that's kind of nice. Now the top is just a little bit um, wrong, meaning if I multiplied the top by I could make it look like the bottom. So let's do that. Let's multiply, and this was raised to the 2019. So let's multiply top and bottom by I. So I'm going to grab I over I, and I'm going to put that inside the parentheses. So I'm going to deal with the 2019 later. And the reason I might do this is if I multiply I times sine and I times cosine, I will get, and I'm going to bring the cosine part in the first, I'll get negative cosine theta plus I sine theta. And then I'm going to just take an I to the 2019 out. Let me write that a little differently. So I've got 1 over I to the 2019. And then on the bottom, I've got the cosine there, and the I sine I can just write as e to the negative I theta. All right, now how can I make the top work out? Well, if I factor out a negative here, then I can have a negative there and make this a negative here. And then I've got basically the same thing that we had at the very beginning of the problem. See how the denominator of the original problem was cosine theta minus I sine. That's what I turned the top into. So now here's what we got. That was raised to the 2019. So I pulled out a 1 over I to the 2019. I have a negative here to the 2019, so I can make that negative 1 to 2019 on top. And on the inside, I've got e to the negative I theta over e to the negative I theta raised to the 2019. So I think it's very possible I screwed up positive or negative there, but that's kind of my thought process. This piece inside the parentheses is equal to 1. This piece right here is equal to negative 1. This piece right here, let's see, if it was 2020, that'd be a multiple of 4. Every 4 copies of I gets you to positive 1. So you could think of there being a cycle where you go I, negative 1, negative I, positive 1 as you go around the unit circle. And so 2019 is 3/4 of that way. So I end up with this being negative I. So now I've got negative 1 divided by negative I, which is 1 over regular I, multiplying by top and bottom by I to make it real gives me I over negative 1, which gives me negative I. So that's one approach. Maybe you like that approach. Maybe you didn't like that approach. Let's try it a different way. We'll see if we get the same answer. Otherwise, I'll really have to think about what I did wrong. The other thought I have is multiplying by the conjugate of the denominator. Because when you multiply by the conjugate, it turns something into a real number. So I'm going to multiply this by cosine theta plus I sine theta, and multiply this by cosine theta plus I sine theta, and we'll see what happens. So do a lot of FOIL. Hopefully things turn out nice. So the bottom becomes cosine squared. Then we have a negative I sine theta, cosine theta, and a positive, so that cancels out. So cosine theta. So here's a negative piece, here's a positive piece, and then I have minus I squared sine squared theta. So the top becomes sine theta, cosine theta. Let's see, plus I squared cosine theta, sine theta. I think I need a little more space. Then we have plus I cosine squared theta plus I sine squared theta. And all that's over 2019. So the bottom is a negative I squared, okay, becomes a positive. Cosine and sine makes 1. So our denominator is actually gone. On our numerator, I squared is negative 1. So I have sine theta cosine theta minus cosine theta sine theta. That's all gone. So what do I have left over? I've got I times cosine squared theta plus sine squared theta, which is another example of 1. So I have I times 1 raised to the 2019, which we just talked about a couple seconds ago, was negative I. Same answer as before. So a couple different ways to do it. I think the second way is a little more elegant. And in general, whenever I do a division problem with complex numbers, I think about using the conjugate. So there you go. Let me know if you have any questions, and I'll help out.